Okay, this is the notes for Section 1.1, Language of Algebra. Section 1.1, to begin with, has a lot of, first of all, a lot of review from your Algebra 1 course, but also a lot of vocabulary that is going to be pertinent as we move through this entire course. I picked out 4 vocabulary terms that you're going to need to get down in your notes that are going to become fairly important as we move through. The first is variable, then expression, equation, and then finally formula. A variable, and all 4 of these should be somewhat familiar to you from your earlier algebra course, but just to review, a variable is a symbol that can be replaced by any one of a set of numbers or other objects. So examples of that would be something like 3x, where x would be that variable, or 2y plus 7, where y is your variable. An expression is a combination of numbers, variables, or operations. So both the examples that I had above, 3x and 2y plus 7, those would be examples of expressions where you have numbers, variables, and operations. So when I have the expression 3x, that means 3 times x. Although there isn't an operation symbol there, it's implied that there is an operation symbol. The third term, equation, is a sentence stating that 2 expressions are equal. So when we talk about algebra, we're really learning a language, okay? And the sentence of this language is an equation. So if I say something to the effect of 2x plus 8 equals 15x minus 9, that's an example of an equation or a sentence in algebra. Okay? And the fourth and last term that I want to talk about right now is the idea of a formula. And a formula is a sentence stating that a single variable is equal to an expression with one or more different variables. Now, you've encountered a number of formulas either last year in geometry or also in algebra a couple of years ago. But an example of a formula would be the area of a rectangle is equal to the length of that rectangle times the width of that rectangle. We have one variable, a, for area, is equal to more than the product or the sum or any amount of operations involving one or more other variables, in this case length and width. Okay, at this point you might want to just take a minute to, if it's been a while since you've read 1.1, you might want to just take a minute, pause the video and take a look at example 1 in your reading, and then start it up once again once you've reread that. But I'm going to now go through example 1 here. It says, Maria collects stamps. She already has 860 stamps in her collection. She plans to buy 20 stamps each month. How many stamps will Maria have after M months? Okay, we're looking to write an expression here. A lot of times we can write expressions or mathematical sentences to model real-world situations. To do that here, we're going to look at the information we have. We know we're talking about M months. Well, that's going to be the variable that we're going to use in our expression. We know that we start out with 860 stamps, and we know that each month we're adding 20 additional stamps. So when I write my expression, I'm going to write it as, here's what I'm starting with, 860. Each month I'm adding to it 20 stamps. Well, to figure out that each month I'm going to take 20 times the number of months. So after 1 month we'll add 20 onto 860. After 10 months we're going to add 200 onto 860. So this expression would model this situation. Okay, one of the things that you're going to be asked to do quite a bit in chapter 1 here is the idea of evaluating expressions and formulas. The term evaluating means if we're going to evaluate an expression, it's the process of substituting numbers for variables in an expression and calculating the result. Something that you did quite a bit of in your first algebra course. And it's really something that we have to make sure that we're able to do still at this point. So what I want to do is I want to first review, when we do that, those rules for the order of operations. And according to our order of operations, we're always going to do, if you remember PEMDAS, we're going to perform anything inside of parentheses or grouping symbols first. And then within that, we're going to take powers from left to right, multiplication and division from left to right, and addition and subtraction from left to right. So that's kind of the order in which we're going to do things, and is going to become pertinent as we walk through each of these different types of problems. So let's take a look at example 2 here. Then it says find the value of this expression here when A is 5 and B is 6 and C is 4, which means that we're going to evaluate that expression. So we're going to plug in these values into this expression. So I'm going to rewrite it right now with those values in there. So instead of A squared and C squared here, we're going to put in 5 squared minus 4 squared plus, instead of C, I'm going to put a 4. And here we would have B squared, which would be 6 squared minus 5 squared plus 4 squared. Okay. Now we need to simplify the stuff underneath the radical, and to do that, I have the square root of 25 minus 16 plus 4 plus the square root of 36 minus 25 plus 16. Okay. This is equal to 9. Just simplifying the stuff underneath the square roots, because according to my order of operations, it's a grouping symbol. I have to do that first. Now this is 36 minus 25, which is 11, plus 16. And 11 plus 16 is 27. So this works out real nice, however this doesn't. Well, the square root of 9, I can simplify that. That's going to be just 3. So I'm left with 3 plus 4 plus the square root of 27. Now I can get an approximation to this. Okay, we're going to talk a lot more about approximations and exact values as we move through this course. You talked a little bit about it last year in geometry. But I'm going to actually leave the square root of 27 just as it is, and I'm not going to simplify that any further. So I'm going to go 3 plus 4, which is 7, and leave my answer as 7 plus the square root of 27. And this is an exact value for this expression. At this point, if you could just pause the video, and for some practice, I'd like you to do guided examples 2 and 3, and then I'll go over the answers here in just a second. Okay, so here's the answers to the first part of guided example 2. You'll notice that for negative b, I'm going to substitute in a 1. For b squared, where you see b, I'm going to put in negative 1. Okay, so all of not just 1, but negative 1 is going to be squared. And then for the other two, this is a 3, a negative 4 here. And then down here we would have a 3. So if we look at step 2 then, the 3 question marks would be 1. So here would be 49, so underneath the square root we would end up with 49. And then this question mark here, where a is, since a is 3, we're going to plug that in for that question mark right there. So if we look at step 3 then, the top value is going to be negative 6, and the bottom value is 6. And negative 6 over 6 would be negative 1. Therefore, when we evaluate that entire expression, we would end up with negative 1. If we look at guided example number 3, it says a kilowatt hour is 1 kilowatt of power used for 1 hour. What does it cost to have a 60 watt bulb turned on for 33 hours at a cost of $9.53 per kilowatt hour? So that's part A. So if I look at part A, to do that, I'm going to say that the cost is going to be equal to 60 watts times the number of hours, which we found out was 33, times the cost per hour, which we know is 9.53 cents. So I'm plugging those values in. Okay. So you need to change 60 watts to kilowatts. Since one kilowatt would be equal to 1,000 watts, we can say 1 is equal to 1 over 1,000. This is the fraction for a conversion factor. Okay? So here's what we have then. 60 times 1 over 1,000, that would be equal to 6 over 100, or 0.06. Okay? Now if we figure out our cost, then it's going to be 0.06 times 33 times 9.53. So if we do that multiplication and division, we end up with 18.87 kilowatt hour cents per kilowatts minus hours. So we're performing those operations on the units just as if they were numbers. In other words, it would be 18.87 cents. In part B, it says let P equal the number of watts in the bulb. Let T equal the number of hours. Let U equal the unit cost in cents per kilowatt hours. Well, then to find that cost, I'm going to take P times T times U and divide it by 1,000.